Hello, AP Stat students. In class, we finished already talking about what a completely randomized design of an experiment is, and we talked also about a randomized block experiment. And that's two of the three types. The type we haven't talked about is what was called a matched pairs experiment. So this video is going to be a quick look at an experiment that we did in class last year with my AP Stat students. We don't have time to do it in our class this year since we're only meeting every other day, but I'm going to show you how this experiment illustrates a matched pairs design of an experiment. So I'm going to share my screen with you and take a look. I'm going to be looking in the PowerPoint, same slides that you guys have access to in classroom. As we look at this, a couple things I'd remind you of. Make sure you're reading the book, obviously. You probably get a little more detail with some of the things in the book that I may mention. I would also look at the videos that I'm going to post along with this. So this is a video of me explaining it. There were a couple of videos that I found just on YouTube that I thought did a great job of summarizing the three types of experiments we're looking at, as well as another one that was about placebo effect and also a double-blind idea. Both of those are pretty short. I'd take a look at them. So here's our third type. It's called matched pairs. And so looking at it, says this is a common type of a randomized block design. So this is a special type of block. And we only do this when we're going to compare two different treatments. And basically what we try and do with a matched pairs design is this. We're going to block people often into this experiment, and every block has to have a size of 2. So we would never do like our blocking experiment about the ACT test program, where you might have 20 students who scored 18 and under, and you might have 20 students that scored 19 and higher. We would never do that in matched pairs. Every block is only going to have 2 people in it. And the 2 people have to be similar to each other, as similar as possible. Now, if they're not identical to each other, there's going to be some differences. And sometimes those differences can make an effect in the experiment and in the results of the response variable. So often what we do is, instead of having a pair of people, we will just have a single person. Like in the experiment, you're going to see each student was the pair of people. And in this case, what happens, instead of having 2 different people that each get one of the treatments, when we do a match pairs this way, one person gets both of the treatments. And you'll see what that means when we do the experiment here to show you the results. But either way, you have to randomly decide, if you have 2 similar people, randomly decide who gets which treatment. And if you have a single person that is the block, then you have to randomly decide which treatment do they get first, because the order you do the treatment in, that could affect whatever you're measuring. So let's take a look. The experiment we did was a pulse rate experiment. The basic question was this: are standing pulse rates generally higher than sitting pulse rates? So I'm wondering, is your pulse rate when you're standing, is that generally higher than your pulse rate when you're sitting? So the way the experiment started was this. We're going to do first just our initial design, a completely randomized design. And what I have students do is, half of the class will stand first and take their pulse rate while they're standing, and the other half of the class will be sitting first and take their pulse rate while they're sitting. Now again, how I decide who gets to stand first and who gets to sit first, that's done completely randomly. So we did this in class. Here's the results. We're using a software program called Fathom. Fathom lets us put some of the results in and build a dot plot from it. So here's what we've got. The first, what is it? All these standards here. The first 15 people in this class, they stood first. And so you can kind of see over here, if I click on the first person, that person had a pretty high pulse rate of 100. Well, this dot plot down here on the bottom is the pulse rates for the people that were standing. There's that person at 100. Looks like kind of an outlier there. The next person was 60. There they are, the red dot. Our lowest person, I think, was this 56. But you can see, here's what the pulse rates were when people were standing. Looks like roughly from about 60 to not quite 80. Most people were in the 60s and 70s here. So what happened to the people that were sitting first? Well, they start down here. I'm going to move this out of the screen just a little bit so we can see when I move this up. But these people that were sitting, their dot plot is forming right above here. This is what we call parallel dot plots. But this person, for example, had a pulse rate of 36 when they were sitting. So there they are highlighted in red. And we have people that are much higher. Here's somebody that was 76, not quite the highest they had. But the problem with doing this, if the question is, do you think there's a statistically significant difference between standing and sitting pulse rates? When I look at these two dot plots, I don't see a real big obvious difference between the pulse rate of standing people versus the pulse rate of sitting people. Standers, if I had to pick just a general center, a typical pulse rate, looks like it may be maybe around 70, a little bit less than 70. If I look at a typical pulse rate, maybe like an average idea for the people that are sitting, might be slightly lower, maybe down here in the mid 60s, but they don't seem very different. Upper 60s, middle 60s, they don't seem too different. Not enough for me to think it's statistically significant, that standing is causing it to happen. I don't see that information here. And the problem with it is our design of our experiment. The reason is the sitters and the standers, you're comparing pulse rates against the wrong people. What we want to see is what would be your pulse rate when you are standing compared to your pulse rate when you're sitting. And what that does, comparing you against yourself, that's like the complete ultimate form of control. Everything is completely identical because you're comparing yourself to yourself. And so what we do is this. To turn this into a matched pairs design, here's what we're going to do. To make it matched pairs, we had all the students reverse their position. So people that were standing, they sat down. People who were sitting, they stood up. And then we took their pulse rates again. Here's what it showed in Fathom. I'm going to pull this out so you see the results. So what we looked at was this. All these first 15 people that were standing, here's their same standing pulse rates. But over here is what they had a pulse rate of when they were sitting. And what we want to look at is what's the difference between them. So I'm going to do the difference as your standing pulse rate, take away your sitting pulse rate. This person right here had a standing pulse rate of 100, sitting was 82, had a difference of 18. That means their standing pulse rate was 18 beats per minute higher than their sitting pulse rate. This person next, they only had a difference of 4, but their standing pulse rate was higher than their sitting pulse rate. If we take a look at what this looks like if I plot the differences, so take a look at what I'm doing. What I'm now doing is a matched pairs experiment. And what I'm plotting now is not the pulse rates of just the sitters. It's not just the standards. Each of these dots now represents what was the difference in standing and sitting pulse rates for a single person. So for example, this first person, I'm going to click on them. They had a difference of 18. There they are, the red dot. The next person here only had a difference of 4. There they are, the red dot. Somebody down here had a huge difference. They had a difference of 48. So they're way over here. But what I'm noticing about almost all of these is that for any single person, remember each dot represents one person and their standing minus sitting pulse rate, almost every single one of them is positive. They're all above the 0 line. 0 difference would mean your standing and sitting rates were the same. A positive difference, so all of these represent your standing pulse rate was actually higher than your sitting pulse rate. There was only one person that was negative. Here they are right here. This person had a standing pulse rate of 64. When they sat down, it was actually higher. So standing minus sitting was -4. But what this shows me pretty convincingly, I think, is that when I set this up as a matched pairs experiment, the standing pulse rates are typically higher than the sitting pulse rates. And I can see that because of the design of the experiment. I paired you up with yourself, your standing pulse rate versus your sitting pulse rate. So that is a matched pairs design experiment. Again, take a look at the other 2 videos to help see it again in a couple different situations to help you understand it. And remember that our test is coming up pretty quick here.